Okay, another chapter 4, section 5 problem, and let's see what it is. It's find decimal notation for a fraction. And they give us some answer choices over here. Find decimal notation, and let's look at the pad, and we'll. Okay, so what I'm doing is this is from an earlier video where I had this fraction, and I kind of talked through, could we turn this denominator into a 10 or 100 using whole number multiplication, and we figured we couldn't. So we just said, hey, let's just see it as a division problem, and we wound up saying 5 divided by 8, and we got the answer on that other problem as being 625 thousandths, okay? Now, the thing I want you to notice as we do this problem is I want you to notice any similarities or differences that we get when we do the same division process on this problem. You with me? So I'm just going to do the same thing. I'm just going to say 7 divided by 15, and I'll just do it right here. Hope I don't find a room. 7 divided by 15, okay? And so I'm just going to put a 0 here and a 0. Zeros. I didn't slash them up here, but maybe that's not the end of the world. Now, well, 15 will go into 7. Put a decimal point here. Now, how many times will 15 go into 70? Well, 5 times 5 is, nope, must be 4. 4 times 5 is 20. It's 60. Gotcha. Subtract. How many times will 15 go into 100? Well, 5 would be, okay, 7 would be 105, so it must be 6. 6 times 5 is 30, 90. Subtract. I'll bring down another one. Now, do you see what I see? Watch this. How many times will 15 go into 100? 6. 90. Subtract. How many times will 15 go into 100? 6. Okay, so I'm going to stop here because I think you see what's happening to us. I want you to please notice that we're never going to get to a remainder equal to 0. Okay, we will never get to a remainder equal to 0. Over here, we did get to a remainder equal to 0 for this fraction. Oh, so please notice, this is called a terminating decimal. A terminating decimal. Terminating. It gets to a point and terminates. Ends. You get a ends by having a 0 remainder. This one is what we call a repeating decimal. Repeating. And in this case, you will notice that the 6 is going to repeat forever. What does that mean? It just means if I sat up here all day and all night and just kept putting in zeros, 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 putting in zeros, putting in zeros, putting in. Okay, so I'm driving you and me nuts. I know that. Please notice these 6's keep repeating. So it's a repeating decimal. How do we write that answer? We don't have to write 0.4 with, pick some number of 6's. I think I'll put 20 in this time. No, I think I'll only put 3 6's. No, we don't have to worry about that. We put in a point, a 4, a 6, and then a bar, a line above the 6 that tells everybody, oh, that 6 repeats. We will have some fractions where the repeating part is a repeating number pattern, not always just a single digit. Okay, so let's go back to Math Excel and notice we got some choices here. Now, what was our answer? Our answer was 0.4 with the 6 repeating. Now, they're kind of subtle in Math Excel. This one would say the 4 6 repeats. No, that doesn't. That's not what it is. This one would say it's a whole number, and then it's no that. And this one, I don't think we need to do that. I think it's this one right here. Do you see? You see, they're kind of tricky in Math Excel. Good job. Good job.